In this session we will see slightly more sophisticated programs. Recall that in our discussion about flowcharts we talked about variables which were conceptually seen as little boxes in which you can hold values. So let us see how to write simple C programs in which we make use of variables. So we will illustrate with the help of a sample program. So we have this following program which is very simple: read a Celsius temperature and convert it into the equivalent Fahrenheit temperature. This is something that all of you must know. So the flowchart is very simple. You have an input C, which is the current Celsius that you want to convert. Then you apply the formula F, which is 9C upon 5 plus 32. In this session we will see how to write simple C programs which make use of variables. Recall that in our discussion about flowcharts we talked about variables which were conceptually seen as little boxes in which you can hold values. Okay. So let us illustrate a simple C program making use of variables with the help of a program. So we have a small problem which is convert a Celsius temperature into the equivalent Fahrenheit temperature. This is a formula that all of you must know. So let's write a C program for it. So we will draw the simple flowchart for doing the program. You input the temperature in C in Celsius, convert it into Fahrenheit according to the formula 9 by 5 times Celsius plus 32. Once you are done that, the variable F holds the Fahrenheit value, so you output the F. So here is the simple flowchart that we want to implement. Now how do we write the equivalent C code? Okay. So in the flowchart we have seen that we have two variables C and F. Okay. These are the variables that we would want to implement in the C code. Okay. So let us see how to do it. So we write the following C program in which now we have two more components. One is the variable declaration float centigrades, and then the second is another variable float Fahrenheit. Okay. So centigrades correspond to C in the flowchart and Fahrenheit corresponds to F in the flowchart. Okay. So I write the following code which is supposed to implement the flowchart on the left. So let's say that the input is 50 degrees Celsius, and then the Fahrenheit, the formula is exactly the same as what we have in the flowchart. We have 9 times centigrade divided by 5 plus 32. Okay. Notice here that these are arithmetic operators. So the star arithmetic operator stands for multiplication, forward slash stands for division, and plus stands for addition. Okay. So this is exactly as in the flowchart, except that here in the flowchart multiplication symbol has been swallowed, but in C you have to specify it using a star operator. Okay. So Fahrenheit equal to 9 times centigrade divided by 5 plus 32 is exactly similar to the analogous line in the flowchart. And finally for outputting we will use the printf statement. Okay. So here is something new in the printf statement. We use what are known as format specifiers. These %F symbols are new and we will describe them shortly. Okay. So let us look at the program in a little more detail. Okay. So we have two statements which are of interest in the beginning of the code, which are what are known as the definition of the two variables. Recall from our discussion on flowcharts that variables are boxes and each box has a name associated with it. Okay. So you have two concepts associated with a variable as far as flowcharts were concerned. One was the box and the second was the name of the box. Now when we come to C, we will associate a third concept with a variable, which is the type of the box. Okay. So if you look at the first statement, it says float centigrades semicolon. Now this defines a variable centigrades it creates a box capable of storing a real number and names the box as centigrades. So the box is of type float. That type float means that that box can hold a real number. Similarly, Fahrenheit is also a box which can hold a real number. So you declare that the type of that variable is float. Okay. So these are supposed to be the first two lines of the code. Now centigrades equal to 50, that is the line which assigns the value 50 to the variable centigrades. So once you execute that code, the box associated with the name centigrades will hold the value 50. Okay. Followed by the line which computes the value of the Fahrenheit. Okay. So Fahrenheit equal to 9 times centigrade divided by 5 plus 32. It's an it associates an arithmetic expression. So it evaluates an arithmetic expression, takes its value and stores it in the box associated with Fahrenheit. Okay. And as we just saw before, star is the multiplication operator, forward slash is the division operator, and plus is the addition operator. Now the brackets in an arithmetic expression are just like brackets in mathematics. So they group together a particular things. Okay. Now let us just trace through the program. Let's see what happens step by step when we run the program. Okay. Let's say that we save the file in sample2.c and then run it as ./a.out. Okay. So first we will have two boxes created, one for centigrade and one for Fahrenheit. These can store float numbers. Now what are float numbers? Basically they are real numbers which are saved by the microprocessor. Now the microprocessor can store real numbers only using finite precision. So this is different from the actual real numbers that we encounter in mathematics. So we have only a limited number of digits after the decimal point, but other than that you can think of them as real numbers. We will see floating point numbers later in the course in greater detail. Okay. Right, for now think of them as the machine representation of a real number. So once you finish the declaration statements, what you have are two boxes, one for centigrade, one for Fahrenheit, and because you declare their types to be float, it is understood that those boxes will hold real numbers. Okay. So let's execute the first executable assignment here, centigrades equal to 50. Okay. And you will see that the box contains 50.000 something. Okay. Even though we specified it as an integer, it will convert it into a real number, a floating point number, and store it. Then this is followed by the calculation of the Fahrenheit value, and let's say that you compute 9 times 50 divided by 5 plus 32, it comes out as 122. After that line is executed, the box associated with Fahrenheit will contain 122. Okay. Then the next line says printf the temperature. Okay. There is no new line, so the next printf will start from where this printf ended. Okay. And here you see something new, which is the %f symbol. Okay. So these are what are known as format specifiers. So the %f symbol says that take the corresponding variable which is given centigrades here now and print it as a float, print it as a real number. Okay. So notice the difference between the first printf and the second printf. The first printf just had a string between double quotes. The second printf has two arguments. One is a string between double quotes and the string is %f, and then the second argument is centigrades. Okay. So it says take the value of centigrades and print it as a floating point number. So it does that, and you see 50.000 in the output. There is no new line, so the next printf starts from the previous line where the previous printf left off. 50 Celsius equals, okay, so it prints that. And now you have another format specifier. It says printf %f Fahrenheit. Okay, Fahrenheit is 122 and it will print it as a floating point number or as a real number. So it will print it as 122.000. Okay, printf Fahrenheit. Okay. So the final message that will be printed will be the temperature 50 Celsius equals 122 Fahrenheit. Okay. So the new thing that we have seen in this program include variable definitions, how they have an associated type, and similarly how do we print these variables. So we don't want to print the names of the variables, we want to print the content of the variables. We want to print what is stored in the box. For that we use these format specifiers like this %f. So let us briefly introduce what are types in C. So variables are the names of the boxes in which to store the values. But these boxes are special. Certain boxes can hold only certain kinds of values. So all boxes are not the same. There are different kinds of boxes. Now types are basically saying that a particular box can hold a particular kind of data. So variables are defined with an associated type, and we will use some basic types during the course of this programming language tutorial. One of the two of the common types that we see in this program are int, which stands for an integer, and float, which stands for a floating point number. Okay, so it stands for a real number. Notice that machines can hold only a fixed number of bits. So int does not mean that the integers can go from -infinity to infinity. It goes from a certain very small negative number to a very large positive number. Similarly, floating point also is limited by a particular range. Okay, this is because machines cannot represent arbitrary values. Okay, the type of integer can store all numbers from -m plus 1 through 0 to plus m. So there will be some large m for which defines the upper limits and the lower limits of the particular machine. Now that limit may depend on which particular machine that you use. Okay. On a 32-bit machine it will be 2 to the power of 32. 2m will be 2 to the power of 32. Okay. A few final words about variables. Just like in a cooking recipe, you will never mention a step which involves an ingredient without mentioning that that ingredient is needed in the first place. Okay, so you will never say that use salt, and if you look at the list of ingredients, you will see that there is no salt in the list of ingredients. Such recipes are considered bad. So when you write a typical recipe, you list out all the ingredients first and then write the steps for the cooking. Similarly, in a program, you define whatever variables that you need before those variables are used by any statement in the program. Okay. Always define a variable before use. Now a word about names of variables. In the C programming language, the names are consisting of numbers, letters, and an underline symbol, an underscore symbol. Okay, and there is a particular convention that a variable cannot start with a number. Okay, so the initial letter has to be a letter or an underscore. It cannot be a number, but further letters can be either capital letter, small letter, or numbers or an underscore. Okay. So there are valid names like C underscore SQ, C SQ1, C underscore SQ underscore 1. So all these are valid. One thing to note is that the names are sensitive to upper and lower case. So for example, capital C centigrade is different from a centigrade which starts with a small c. So these are two distinct variables. Okay. That's a common source of errors when you start programming. Another thing to note, to watch out for, is that the assignment operation, which is equal to, is not the same as the mathematical equal. So when mathematically we say A equal to B, it means that A and B are the same quantity. So A equal to B is the same as saying B equal to A. This is not true in C. For example, let's say that you have the statements B equal to 3 semicolon, and then later you have A equal to 2 semicolon, and further you have the statement A equal to B semicolon. So the statement A equal to B will set A to B's value. So B's value is 3, and that value will be copied to A. So it will set A to 3 and B will be unchanged. Okay. So watch out for this. If you were expecting the mathematical operator, after the operation A equal to B, A and B will have the same value, but that is not the case. The meaning of the symbol equal to is that take the value on the right hand side of the expression and copy that into the box specified by the left side. Okay. So copy the value on the right hand side to the variable on the left.